Okay, so now that you've had a chance to practice how to find the inverse of a matrix, bless you. We want to make sure we know how to write a matrix equation to solve a system, all right? So this is going to be very complicated, probably take about 20 minutes to do one problem, okay? So you want to write really small, okay? Really small while you do this, really small. I'm not lying, okay? It's going to take a while, all right? Yes, we'll see. Let's get going. All right, so here's the system. Does everyone see the system? You can do this, Alonzo, I promise. Here's the system, right? If it's not going to be helpful for the class, then don't say it. All right, if it's not going to be helpful, let's not say it. All right? Let's stay focused, right? All you're doing is distracting me and other students. Okay, you know who you are. Let's keep going. So here is the system. The first thing you should do is you should write the coefficient matrix like we did yesterday with Cramer's rule. All right, what's the coefficient matrix for this system? 1, 1, 2, and 1. So write that down. Remember writing small. All right, I'm going to label this matrix A. Now, we're going to go further because today is not Cramer's rule. We're going to write another matrix, times. And this matrix is the variable matrix. What are my variables in this system? X and Y. All right, that's called the variable matrix, and I label that matrix X. Equals. The last matrix is the constant matrix. What are the constants after the equal sign? 8 and 1. And I label that matrix B. All right? If I don't see this matrix equation on the test next week, you will not get full credit. All right? So that's the first thing I'm checking for. You don't have to put the letters up top, but I have to see the matrix equation. So that's the first thing I'm checking. Questions on that? Okay, that's brand new. Now, once you write this equation, we need the inverse matrix of matrix A. So I'm going to find the inverse matrix of matrix A. And before I do that, what's the first thing I need? Before I even do that, the determinant of matrix A. So I'm going to find the determinant of matrix A with 1 times 1 minus 2 times 1. And what is 1 minus 2? It is negative 1. So the determinant of matrix A is negative 1. Everybody still with me? Remember, ask questions if it's about the material. If it helps us move forward, I'm happy to answer that question. All right, so I'm going to write for the inverse equals 1 over negative 1. Remember, I'm putting that in the denominator. Times, okay, now here is that switch ops. The 1 and the 1, that first diagonal, they switch places. Now you might be thinking, well, they're the same, but make sure you switch them. All right, I'll know if you didn't switch them. Okay, I'll know. Okay, so those switch places. Now the other ones, the other diagonal, those are the opposite sign. Those are the opposite sign. So it's negative 2 and negative 1. Everybody still with me? Okay. All right. Now, to find the inverse, you're going to take all 4 numbers and divide by a negative 1. Now, because you're dividing by a negative 1, they're all going to be the opposite sign in the end. Now, I don't want you to think that, oh, I changed them to be the opposite. No, I divided them by negative 1, and that's what happened. They become the opposite sign. So we have negative 1, positive 1, positive 2, negative 1. Okay, questions so far? Yes, Aviana, it's not it, no.
So you're just explaining just now, like this is all the case for this movement.
Correct. What I was trying to say is if this isn't negative, let's say it's a positive 3, then I'm dividing all these numbers by 3. So you have fractions or decimals. What students sometimes think, Aviana, is that, oh, you just made them the opposite. Like, no, I didn't. I divided them by negative 1. And when you divide anything by negative 1, it changes the sign. All right? Cool. All right, so what I want you to do right now is I want you to put your pen or pencil down. All right, so pen or pencil should be out of your hand. Yours shouldn't. You should be copying that. Okay, great. So everyone else should have their pen or pencil down. You should not be writing what I'm about to write. Okay? All right, here we go. So bear with me. I'm going to take that inverse matrix right here. That's the inverse matrix for matrix A. And I'm going to write it. You should not be. I'm going to write it in front of the left side of my equation. You can do this, Frank. Okay, everybody still with me? Remember, see how I just wrote the left side of my matrix equation, and in the beginning I wrote the inverse of matrix A? Okay, now I'm going to write the right side in the same fashion. Still with me? Okay. It's good times. Okay. You should still not be writing this, right? I mean, did you finish up to there? Great. All right, so you're still not writing. Does everyone see what I did? All right, the reason that I did that is because I'm going to show you, you're not going to write this down, I'm going to show you that if you multiply out all three of these matrices on the left side, you're going to be left with just x and y. Okay, let me show you. Ready? It's exciting. Oh my gosh. Okay, so this matrix is a 2 by 2 matrix. This matrix is a 2 by 2 matrix, so it's possible. So I'm going to multiply the rows times the columns like you've done before. Okay, still with me? All right, here we go. Ready? See if you can follow along. -1 times 1 is -1. 1 times 2 is 2. -1 plus 2 is +1. Remember, you don't have to write this down. -1 times 1 is -1. 1 times 1, when you add those together, you get 0. Okay, keep going. 2 times 1, 2. -1 times 2, when you add those together, 0 again. 2 times 1, 2. -1 times 1, when you add those together, you get +1. This right here, this matrix that has 1s in the first diagonal and 0s in the other diagonal, that's called the identity matrix. All right? And this matrix is important because whenever you multiply this matrix times any other matrix, like x and y, you're going to have the result of x and y every time. Okay? Let me show you. You ready? Okay. So this one's going to be a 2 by 1 in the answer. What's 1 times x? X. What's 0 times y? 0. So x plus 0 is x. 0 times x? 0. 1 times y is y. So 0 plus y is y. So all of that work I just did, you'll never have to do. Okay? But I wanted to show you one time why we do this, because multiplying the inverse matrix of matrix A times matrix A gives us the identity matrix, which then I multiply times my variable matrix, ends with the variable matrix. Pick up your pen or pencil. There you go.
Are we going to get that every time?
Every time. You don't have to write it, but that's how it works every time. Okay? No, don't copy it. I should have made, sorry, I thought I made it very clear. You're not writing that. You never have to do it. But I wanted to show you one time because it's good for your brain to see why. Okay? So what you should write down right now, let me box it right here. You should write down this. All right? You should write down x and y, that matrix on the left side, and then my inverse matrix times my constant matrix. You're going to have to show that one. Almost there, Alondra. So close. I'm so sorry. I hope you feel better soon. I was that way a few days ago. I don't wish it on anyone. It's so sad. All right. Here we go. This is a 2 by 2 matrix. This constant matrix is a 2 by 1 matrix. How do I know if it's possible? You check the inside numbers. Do you see how the inside numbers are both 2? That means it's possible. And what are the dimensions for the answer? A 2 by 1. All right? So for my work matrix, it's going to be a 2 by 1. All right, so I'm going to multiply the rows of the first one times the columns of the second one. All right, so here we go. -1 times 8. Excellent. Plus 1 times 1. Say it again. Aviana, question? We're multiplying. -1 times 8 plus 1 times 1. That's what we did last week. Okay. The second one is going to be 2 times 8 plus -1 times +1. Okay? Everybody good? So now we're ready to write our answer. If you're not good, please raise your hand and ask. Why are we adding? Why are we adding? Because you always add when you multiply matrices. So what Aviana, your brain is thinking about is determinants. Determinants is when we use subtraction. So you got to organize that in your brain before next Wednesday. Determinants, subtraction. Multiplying matrices, we'll use addition. Okay? So here is -8 and a +1. What's -8 and a +1? -7. So that's our x value. And then 16 plus -1. 16 plus -1 is 15. And you can leave it like this. I always just like to write it as an ordered pair. But I will allow you to leave it like that. Both are cool. Okay. Questions on this process? Because that's it. You did it. Only 15 actually. Not bad. Now, what I want to make sure you understand is what work do you need to show, right? Because on the test, you want to make sure you get full credit. So you have to start out by showing the equation, all right, the entire matrix equation. So when you practice, start with the matrix equation. Then you've got to do all the work to find the inverse of matrix A, okay? So you're finding the inverse of matrix A. Then, remember, you're only showing, I guess I should do this work. Right? So you're showing this, then that work, and then the answer here. So you don't ever have to do the multiplying here to get the identity, and you don't have to do the multiplying to get that. You know it's going to be x and y on the left every time. Yes, so that